From the human perspective, sea slugs may as well be aliens from another planet. It's hard to imagine what it's like to survive in their liquid world, and the science is just beginning to reveal their bizarre adaptations. But over 3,000 species of sea slugs have mastered this ocean landscape, and the secrets to their success are nothing short of superpowers. Just like snails in your garden, sea slugs leave mucus trails behind them too. This is a sea slug predator called Navinax. Navinax not only leaves a trail, but is highly tuned to follow them as well. This sea slug is a Janylus, and the structures along its body are called serrata. Serrata help a sea slug breathe, digest, and even defend itself. Which is a good thing for this Janylus, because it has no idea it's being stalked. Once in striking distance, Navinax lunges. Like a coat of arms, Janylus flares out its serrata, keeping Navinax from reaching its vulnerable body. With a pause in the onslaught, Janylus curls up into a ball and rolls away. The hungry Navinax is left unsatisfied. Sea slug antennae are called rhinophores and are used to smell the seawater. The black dots you see are primitive eye spots for telling light from dark. Their hearts pump blood directly from their serrata into their body. No veins or arteries required. And the serrata, again, are multi-purpose. This Spanish shawl stores stinging cells from the food it eats in their bright orange structures. Amazingly, the Navinax can sense this just by touch. The predator moves on in search of something a little less spicy. Close by, a Hermesenda sea slug has taken a wrong turn. Navinax has picked up on the trail. Hermesenda has stumbled upon a patch of tiny skeleton shrimp impeding its way. Unable to make a run for it, it's no match for the hungry Navinax. Closer to the surface, life seems more slowly paced for this California sea hare. Sea hares love red algae. It's the key to their unexpected superpower, and they eat so much of it that they turn red too. But danger lurks in the darkness, and our sea hare is being watched. On this reef, Food is scarce, and a passing sea hare is just too tempting for this lobster to ignore. The lobster drags the sea hare into his cave, and instinctively, the sea hare rolls into a ball for protection. The sea hare reveals its powers. First, the sea hare secretes a substance called opaline. This sticky substance covers the lobster's appendages, flustering it. But this lobster isn't giving up. Stage 2, bright purple ink, derived from the red algae it eats. In a process called phagomimicry, the ink provokes a feeding response in the lobster, enticing it to eat the ink instead of the sea hare. The sea hare may be slow, but the lobster is confused and preoccupied. It eventually makes its escape, leaving the attacker with nothing but a mouthful of ink. Though sea slugs may seem lethargic, that's not always the case. Take this rainbow nudibranch. Its secret lies in its serrata, which are finely branched to absorb as much oxygen as possible. It moves slowly across the ocean floor in search of a meal. On the menu, tube anemones. So begins the climb. Too slow. Success is going to require a little more speed. Starting over, the rainbow nudibranch extends an oral veil from its mouth, allowing it to capture the anemone's stray tentacles without alerting it. Once enough have been gathered, it bites down, getting a free ride down the tube. The rainbow nudibranch will eventually incorporate some of these stinging cells into its serrata and use them for defense. It's this ability of sea slugs to use the tools of the creatures around them that make their adaptations so spectacular. One of the most remarkable examples of this was recently studied by scientist Pat Krug at Cal State Los Angeles. Pat is investigating how these Elysia sea slugs are using chloroplasts from the algae they eat to continue growing with little to no food. To test this, he's been controlling the amount of light exposure on these sea slugs.
So it's been 3 weeks with this slug getting artificial sunlight and this slug being held in artificial shade. And what we can see is that the slug that got sunlight grew a bit more than the slug that was held in the shade.
Pat's experiment proves that these little sea slugs are harnessing the power of the plants they eat to tap into the energy of the sun. Imagine if you could eat some leaves and then for weeks thereafter survive solely off of sunlight. That's what these guys are doing. With over 3,000 species of sea slugs on Earth, who knows what other secrets this incredible group of animals is hiding.